As you've seen in the lectures or the other lecture videos, topics like inheritance and polymorphism, well, they're among my favorite topics and the things that when I was a student fascinated me the most about object-oriented programming. It's sort of hard to come up with interesting and I guess practical examples that are accessible. So inheritance is used a lot in object-oriented languages, but for introductory examples, it's hard to find something that is both actually useful, so meaningful, that is, I'm sort of saying, not like the examples where we just do, classes representing fruit or something, but also, something we can understand at this level. So I'm hoping that ChatGPT has some interesting ideas. I'm preparing myself to be impressed by this. I figure the first thing I'm going to do is say, give me some exercises on inheritance, because I think it'll get my drift a bit better that way. I'd also like to see what happens if I say, give me exercises involving polymorphism. I generally would rather just call the whole topic polymorphism, because inheritance is sort of a way that we can implement a form of polymorphism. But I'm going to start with inheritance. I just learned about inheritance in object-oriented programming using C++20. Wow, inheritance is really interesting. Can you generate, I'm going to just ask for one exercise because I think it seems to be better at generating one exercise at a time. A programming exercise involving inheritance, consisting of some starter code with a class or classes missing, and a main function with a set of test cases already written. Include a formal specification as a header comment for all classes that I am supposed to implement. Don't show me the solution. Of course, here's a C++ programming exercise involving inheritance for you. This it focuses on a simple scenario involving shapes. I see. I'm beginning to wonder if maybe ChatGPT went and ingested all of my programming examples as part of its training. Okay, I'll need to create a base class. There's shape. There's rectangle. Okay, triangle. I think we're going to need a different one. That looks nice, but I've already practiced with shapes. Can you generate a different exercise? Nice try. Certainly, here's a different one. Okay, we've got vehicle. This is looking a bit better. I'm noticing quite a bit of notation here. So it's generating some pretty complicated looking code, although I think it's all at our level. It's just full of lots of special features. So I've got a class called vehicle, a class called car, and a class called motorcycle. This is a pretty common style of exercise. I remember seeing, I've seen exercises about vehicle and car and truck and stuff in textbooks. So I'm not surprised ChatGPT went there, but it's a good one. Let's copy it and take a look. Okay, so we'll paste it in here. I'm also sort of interested because this has required ChatGPT to generate data as well, and I've been a bit contrary about how when ChatGPT generates people's names or the titles of books, it has a certain bias. For cars, I don't know what to expect, but it looks like, yeah, okay, Toyota Camry, okay, and Harley Davidson Sportster, okay, it can think of the name of at least one motorcycle. That's something that it has on me at least. All right, so what do I want? I've got a variable called car. Okay, I'm going to use the curly brackets here. I just can't stand the round bracket initializers where they're not needed in C++. And I'm going to call a function display info. So I'm not going to need a print operator. In that last video, it kept asking me to write stream insertion operators. Okay, so I've got this function called display info, which is a virtual function, a virtual abstract function in the base class vehicle. So that's interesting. And then I've got in car and motorcycle. So it's pretty clear that I have to implement display info because, as we can see, it's pure virtual. That equals 0. So this is material from this week, but it's pretty late in the week, I guess. This material that allows us to write pure virtual functions. This is me saying in the vehicle class, there needs to be a function called display info info, but I will not provide you an implementation of it. You are required to override this, and you are required to implement it as you see fit. There are protected members, make, model, and year. It's done this annoying thing where it names the members with an underscore at the end. That's a convention in some contexts, especially in other languages, not as much in C++, where you use an underscore to indicate this is a private member. I'm going to leave it in because I don't think removing it I think it'll take a while to remove it. I don't like it, but that's just the way things are. Here I have a constructor with interesting parameterization. You'll see that, okay, I take a string for the make, a string for the model, and int for the year, but notice how this equal sign is provided to give a default value. This means that if I want, I can call the constructor with no arguments, and it just uses these default values for each argument. And we've seen this in this course. I don't tend to use it very often, but we do see it. Now, it's already written for me some stuff. So I've got this, the vehicle class appears to be done. I've got my car class. This constructor seems to be complete. So it takes the make and model, the year number, and how many doors the car has. That's clever because cars have doors and motorcycles don't. And so vehicle can't have a doors member, but cars can. It then delegates, it then calls the vehicle constructor, so the base class constructor, with the make, model, and year provided. It's not using curly brackets, which I hate, so I'm going to change that. And then it initializes its member num doors to be the value that was provided. So I'm going to use curly brackets for that as well. All right, so we're actually seeing some stuff that requires a lot of the notation we've seen this week. This is not really an introductory example of using inheritance. And then I'm going to want to implement display info here. Motorcycle does something similar. Let me just fix up the notation there. I'm going to use curly brackets. I guess I could just ask ChatGPT in my future prompts. I could say always use uniform initialization. None of this round bracket business. Okay, so I think I just have to implement these functions. So I'm going to go grab the signature for display info. Before I do that, I'm going to try compiling it because I want to show off that it's going to have a problem with this. It has a couple of issues. So the issue here, it says I can't construct the object, which is weird because you think there is a constructor and the class exists, but it's saying I can't declare it to be of abstract type car. And then it says, because, it later adds a note, because the following virtual functions are pure. That is to say, there is this function display info in the parent class, in the base class vehicle, that is pure virtual. And I haven't overridden it, which means by default, the version of the function I get in the car class will be the pure virtual version from the base class, which should never exist. You are never allowed to create an instance of a class that has pure virtual functions. You're allowed to define a class with pure virtual functions and inherit from it, but you can't create an instance. So I would never be allowed to create an instance of type vehicle. That would not be allowed because there's a function that doesn't exist, that is pure virtual. So until I define display info, I'm not allowed to instantiate the car class. So I'm going to go grab the display info function. I'm going to put it here. I'm going to write the word override, and then I'll write the implementation. Actually, I'll try compiling and show off that this makes the error go away. There we go. So there's my compile command. It's now complaining about motorcycle, but it stopped complaining about car. Now, it looks, this is pretty clear. I sort of know what it wants here. It just wants me to use a print statement that prints them all in one line. So I say car, and then I print out. So the member that I want to print out is make, but you'll see it's not actually a member of the car class. It's a member of the parent class vehicle, but it's protected, which means I'm allowed to use it in a subclass. So the car class does have access to the variable make. So I say make, and then I do a comma model, and then I print out model, and then I do comma year, and then I print out year, and then I do doors. And then I print out num doors. And then I don't print a new line because that's not the point of display info. Maybe it is. It's not a print operator, so I guess it might need a new line. I'm going to split this over multiple lines so that it doesn't wrap around. There we go. And then, to be honest, I think display info is going to be the same in motorcycle. I'm just going to copy it. It requires very little extra work. Okay, so I print out the year, and that's where things get different. So I'm going to print the year out, and then I'm going to just add this extra bit here. It looks like it wants me to print literally the word yes or no based on whether it has a sidecar, which is something the motorcycle can have and the car can't. This is why ChatGPT is so valuable. Coming up with this exercise would have taken me so long because I would have had to think of something motorcycles have that cars don't. So I guess what I do is I just say if has sidecar? And then if the answer is yes, then I print out comma sidecar yes. And then if the answer is no, so I'll just do an else, then I print out sidecar no. All right, let's just see what happens if I run that. Okay, so car Toyota model Camry year 2020, doors 4. Yep. Harley Davidson model Sportster year 2021, sidecar no. I will see what happens if I set sidecar to true, but beyond that, I think that's all the testing I need. The fact that it compiled is pretty much, and the fact that it runs and gives output on these inputs, I think is sufficient. Yeah, it's able to print out whether it has a sidecar or not. Okay, so that's exercise 1. That required some higher level inheritance notation than I was expecting, but that's good. It's off to a good start. That was great. That was good. Can you generate another? Okay. See what it comes up with. Certainly, here's another one. Okay, we've got employee, and the employee has a salary. Notice again, there are 2 pure virtual functions. So this is an abstract class. Employee is not a class that you're supposed to instantiate on its own. It's only there to be the base class for something else that fleshes it out, that fills in these details. Great. I then have the full-time employee, okay, and I've got part-time employee. And is that it? Yeah, that's it. I wanted to give me one with at least 3 layers or something, 3 layers deep. This is interesting because it's going to tell us a few things about what ChatGPT thinks about employees' names, for which it might have a bias, and what it thinks people's salaries are, which, and I assume it's going to be working in American dollars, but it'll allow us to learn quite a bit about what ChatGPT internally, what information it's working with. So I'll clear this. I'm going to make up a compile command for practice inheritance 2. And I'm realizing as I see these exercises, we can sort of see a pattern, like this is the same output formatting that it gave us in exercise 1, because probably it's synthesizing these exercises from the idea that we can have multiple types of employees and this basic notion of having a base class and 2 derived classes. I'm thinking in the next video, I might ask for, I'll say, give me polymorphism exercises, and I'll give it much more specific prompts, like I'd like the class hierarchy to be 4 layers deep or something, as a way of trying to provoke it to give me something a little bit outside of this mold. Because I wouldn't be surprised if this is pretty much the same deal, even the same function name as the last exercise. Okay, so I've got my base class. It's got 2 pure virtual functions. I'm going to just copy them right down and begin implementing them because I pretty much know what's going on here. I am going to fix up some of these round bracket things for the sake of the version of the exercise that I save for later. And then I'll just paste this in and I'll just write the 2 functions. Okay, so calculate salary should return the fixed salary. Okay, what's that? Well, it looks like a salary is passed in the constructor. So I just return that, I guess. So I return, there we go. Display info should print out in pretty much the same format as we were using in exercise 1. All right, so I'll just do that. I'll just steal the specification and fill in the blanks. Okay, full-time employee, this is way faster. Name is, and then I push in, the member would be in the base class. It's called name. You can see it's protected, so I'm allowed to use it in the derived class. The name is name, and then I'll just go to the next line, cout, gets, and then comma, comma ID is going to be, and then what's it called? It's called employee ID. And then underscore. Is that, did I spell that? Yeah, that looks good. And then we do salary. And a $sign, and then I push in this salary. And then I guess I'll push in a new line. All right, so I'm going to copy and paste both of these down into part-time employee because I'll bet that the answer is pretty similar there. And it looks like there's something more complicated happening with the salary calculation. This is interesting. So I'm going to change the way I implement display info to accommodate this. So I'm going to calculate I'm actually going to call calculate salary when I print the salary out. So that way, if the salary calculation is weird, I won't need to worry about it in the print function. And I probably should have done that up here too. If I want the salary, why not just call the function that gets me the salary? So display info is almost identical in the two versions, except for this sort of deliberate change of writing part-time employee instead of full-time employee. If it just said employee and everything else was the same, then it should be in the base class, but it doesn't, so whatever. Okay, now what is the salary? So here, for part-time employee, I'm going to fix up the curly brackets. For part-time employee, it looks like instead of taking the salary as just a number, like the final number, it takes in the hourly wage as well as the number of hours that were worked. So I guess the salary is just those two things multiplied together. So I'll just do that. So, okay, return hourly rate times hours worked. We can see a sort of an interesting observation about how ChatGPT thought of this problem. In the other parts of exercise 1 and this exercise, it's done this obnoxious underscore notation to name all the members, because that way it can take in salary as an argument to the constructor and then have a different name for the member, so there's no confusion, even though I'd rather be confused than see this underscore here, but that's just me. It did that in almost all of this exercise and in all of exercise 1. But for some reason, exercise in part of this exercise, so in the part-time employee constructor, one of the members doesn't have an underscore. Oh, wait, it does. Wait a minute. What? Is that wrong? I think I might have deleted the underscore by accident. I was about to point out what an odd inconsistency, but then it turns out maybe that ChatGPT was being consistent and I was the one with the inconsistency. Yeah, okay, it was there all along. Never mind. Ignore the last 30 seconds. I'm not going to edit it out, but just you go back in time and ignore it. So I'm going to print out hourly rate underscore times hours worked underscore. And we'll see if that compiles. If not, then I've put my foot in my mouth again. So, okay, there, it looks like it did. So I figured that out. Practice inheritance 2. Okay, our two employees, John Doe and Jane Smith. Fair enough, whatever. And the ID number 12345678890. Those are getting printed out correctly. John Smith's salary is $50,000. So these are 50,000 US dollars. I don't think so, because ChatGPT learned all of its information before 2021 or something. I don't think it's accounting for cost of living increases. Jane Smith worked at an hourly rate of $15 per hour. For 30 hours, which should come out to be, 450 looks about right for that. So okay, it looks like my calculations are being done correctly. It's also neat to see what ChatGPT comes up with if you ask it for salary information. You might want to ask ChatGPT, but ask it stuff like, what do you give me some examples of typical software engineer salaries, or typical computer engineer salaries, or typical mechanical engineer salaries, or typical university faculty salaries. It would be interesting to see what it thinks the answer to that question is versus what, let's say, Google thinks the answer is, or what the average person thinks the answer is. That's a topic for some other time. Okay, so we've done 2 examples of inheritance. I feel like if I go and ask for more exercises on inheritance with the current ChatGPT session, I'm just going to get more variants of this exercise. Exercise 2 and exercise 1 were very similar. So instead, I'll make a different video where we ask it for polymorphism exercises and hope that it comes up with something a little bit more creative than this.